Hi, good morning. It's already third week of the semester, so maybe next week, so it will be a quarter will be gone. Sometimes when some of your high school already grade for the quarter report, so but we do not have the quarter report. However, you should be a little bit more serious to prepare your midterm final and the project everything. So it's not easy to do at one time. So do not expect any delay or the extent of the due date. So you should be ready for the other activities. So and also today we are going to continue and finish the chapter 2 regarding to the operating system structure. And also, if I have time, so we can start the process management. That is a really main part of the operating system. However, so we have the scheduled operating system exercise lab. Probably by I think October, you need to bring the laptop every Wednesday. Or why don't you bring it? I think nowadays most of the students carry on your laptop, so be ready anytime to do the exercise lab. So if we need the time, we will do the exercise lab. One more thing is regarding to the GCP lab, which we are not going to cover in the classroom. We don't have time, so I ask you to study by yourself. But for those who are not familiar with the cloud computing or the command line interface like the Linux and Unix system and the product on GCP, so I'd like to offer the extra exercise lab only for the GCP next week. Friday. It's not confirmed yet. I need to find the room that can have the database class, operating system class, and also the data mining. It's around 70, so 150. Now, I don't think all students attend, but I'm thinking the bigger room. Then it will be probably the next week Friday, so noon to 12:30, then 1.5 hours to 2 hours, the extra exercise lab. Only for it's optional, you don't have to if you are busy, but once the schedule is confirmed, so I will let you know through the campus message. So which will cover the GCP exercise lab that through 1 through 7, something like that. We did only first one to create the project only. But for your better understanding of the cloud computing, GCP, so the GA and me, are working to offer the extra exercise lab. Any questions so far? So we will have a lecture today, maybe 30 to 40 minutes, and the other half will be the operating system exercise lab, which cover the very basic command of the Unix shell. Okay, using the compute engine, virtual machine that you created. So if you do not create yet, so please create. I don't think it's a good idea to create in the middle of class because you do better pay attention to the lecture. But if not, so please be ready for the operating system exercise lab. So until last class, we talked about what is the main component of the operating system. First part, we talked about in chapter 1, what is the operating system, plus the computing architecture. To understand the operating system, definitely we need to know about the computer itself. So to use that computer resource, we are going to build a software that can be interface between the user and the hardware resources. So main job of operating system is the resource management, okay? Also resource allocate and coordinate and control. These are the main job. So to do that, so we have the several components of the operating system starting from the hardware and the user. So in between, everything in between this one is the main component of the operating system, like the graphical interface or the command line interface or any other interface. And we have the system library or system core, and also we have the other main module of the operating system like the file system, process management, and so on. So we will cover all of this throughout the semester. So mainly there are 3 parts of the strategy. actually the system library is also categorized into the three parts. One is the process management, another one is the memory management, the others are I/O management. Actually, that is the main component of the computer architecture. Computer has the CPU and the memory and the other I/O devices. It's the same thing. So we will cover chapter 1, 3 to 6, process management, 8 and 9, memory management, 10 to 13 will be the I/O management. That is the overview of the operating system structure. Then, so to speed up for the rest of the part of the chapter 2, I'm going to use the slide. Okay, so based on that, there are various different types of different architecture of the operating system. Some of them are very simple, and the others are very, very complicated. So simple structure, have you ever used MS-DOS? Yes? If you agree, means you are a little bit old-fashioned. Okay, so when I learned the computer first time, I learned the MS-DOS. Okay, so everybody knows what is actually the MS-DOS itself, even though you never use it. But as you implied, this is operating system also, but very simple operating system. So what kind of the functionality does the MS-DOS have? Copy, right, and others. Create the directory. So you can create the directory, make a directory, and rename and so on. Such a command, actually that will create the process. Okay, when you type the copy actually create the process. Then the contents of the source of the file move to the destination file. So that is a copy command. And then actually the Bill Gates, from his project, so he started to build a more convenient and efficient operating system based on MS-DOS. He actually would like to add the other components. So MS-DOS is in charge of the little bit of this process management and the process management and the memory management and the file management. The only part of it. It's a very simple operating system. It was enough to handle the small number of files or a small amount of information, but it's not good for the personal computer 1980. At the time, the personal computing power is getting bigger and bigger. IBM XT, IBM AT, or the Macintosh is getting powerful, the CPU and the other thing. So he developed on top of this one the new operating system, which is the MS-DOS, like this one. So the MS-DOS is here. However, that's not big enough. He add more application program, others, then eventually build the Windows, the operating system, by the revolutionary changes on interface part, especially. It tried to use the Windows. However, Microsoft, the Windows is not the operating system that used the Windows concept. Do you remember the OS2 from IBM? Personal Computer OS2 also used the exactly same concept for their interface, Windows. So, but finally, the Windows, Microsoft Windows beat the IBM, the OS2. By the way, anyway, go back to this structure. It's a simple structure. The main problem is he add a new component of operating system like the graphical user interface, like the window and other thing. Then he build the new operating system. That's the Windows. Problem. This one is also operating system, and there is another operating system. Under one roof, there are two. Okay, families. It may be possible, but always fighting each other. It's your job, it's my job, and conflict situation. That caused a lot of problem of the Windows. Until when? Windows 95. Okay. Then finally, the Microsoft Windows gave up to use the MS-DOS. Okay, and take out that part. Instead, similar, just application interface CLI, but CLI is not the operating system. It doesn't create the process. Okay, instead, it's just the interface to run some mostly icon-based. Click the icon, then process, starting the new process. But sometimes you can type notepad from the command line. But that doesn't mean that the CLI create a new process. Instead, it just the really interface to create a new process. So after that, the Windows, they support only the Windows NT, network-based multi-user system. But people who have used a lot command line interface, okay, they like such an interface and the operating system like the Linux or Bash shell, okay, which are still existing in the Mac OS, okay. Then finally, the couple of years ago, Microsoft Windows going back and they adapt plug in the Bash shell as a part optional. So as a default, Windows 10 does not have the Bash shell, but if you want to, you can install the Bash shell. Okay, that is a shell program. So shell program is not like this position. Shell program itself is the one component as an interface of the operating system, which means it's a little bit messed up architecture. Their architecture of the Windows, because of that, sometimes it causes a lot of issues in from their operating system. Some of them are very simple, but Unix is non-simple, so they have basically kernel. So if you start even including the virtual machine on GCP, when you start up, you can see the kernel name and the version, because based on that, there are a lot of barriers, but their main part, when we decide what kind of the Linux system, what kind of Unix system you use, you can just check the kernel. Just like when you are using the cell phone, Android cell phone, so it has Marshmallow, what is the current version? So the whatever is a kernel name, kernel version. So this kernel actually is the operating system structure. This is a very, very simple family tree. In the tradition, it is very important to keep track of the whole family tree from the third, fourth, or 50 the ancestor generation, and keep sometimes the 10 or 20 groups to keep record of all the family tree. What are the Unix? Unix has such a family tree. It started from as I said, 1969 happened a lot of things. Do you remember? Neil Armstrong landed on the moon first time. It's around July. And also Dr. E.F. Code proposed the relational data model if we are taking the advanced database course. Then also Unix. There's the first Unix system was developed and tested, and from 1970 it started. So because of that, do you know you turn off, okay? Turn off the computer, but after turning on, your time is correct. How? There's a battery inside, okay? So there is a battery inside. Without battery, so there's no way electronic device without power running on. So to keep such the information, so there is a battery. However, what if it's out of battery? You may replace, but just suppose that we replace. Then at the time, when you start up, everything is new one. Then its time will be 1970, January 1st, the 0000. Always. You may not see the default time, 1969 is the start, 1970. Some of the process is the starting time is 1970, because that is the first time of the Unix kernel started commercialized. Okay, so that is the reason it's 1970. There's one more thing happened, 1969. No, you don't remember? Yes, I was born. 1969. Keep remember? Who knows?
Is it going to be on quiz?
Not quiz, it's a midterm. Okay, so this is there are two main variation of the Unix tree. One is the Berkeley system, BSD, and another one System R project. But this one is used a lot the Berkeley the system. Anyone can help? What? So this is actually the real version of the Unix, the family tree. Starting from, what is the year number?
69.
69. Starting from the 69, I give up to update. It is to 2012, 13, the 14, and 6. I think the 16 is the last one. There might be more. Okay, so this is only for the Unix, the kernel, including the Linux, and so some of them are, you can see the Mac OS and the iOS, so something like that. It is not the brand new development. Most of the current commercialized Unix system is from one of this branch. Okay, then they usually rebuild and revise or add or remove. Then rebuild the kernel. Then you can put your own version of the Linux or Unix system. Okay. Do you need to memorize? Just leave it. Okay. So this is, you can find this one from I think the top one. But you don't have to memorize, but you better know the Unix and the Linux system is not like just a simple operating system. It has a long time history. Okay, and also if you want to make, I have a new idea for the process management or creating. You can add a couple more things, then this is your own version. You can name it. Red Hat, CentOS, Debian, and there are a bunch of different names of operating system, but they have started from the same kernel, then the different the little bit functionality or the interface. Okay. So this is already we discussed. Then depending on how to organize, how to communicate such a module, sometimes called a module, sometimes called a component of the operating system, there are different approaches. One of the most popular one is a layered approach. Layered approach means, so it's like the archery, the target, but in the middle, it is a hardware. Each hardware has the specification, plus it has the device program. So device program is usually, where it is? Controller. So do you remember when I showed the computing architecture, each hardware device, then they are connected through the bus, but when each device, I/O device connected to the bus, it needs the controller, because each and every device has different specification. Different rule of to use the port. Okay, for example, the serial port or the 90 port, it has a detail. So sometimes you can use this port for the mouse. It's up to you. If you define this one is a signal or the input signal, output signal, something like that. Who knows that? Your device, the controller, device program on the controller knows this one. So that is up to this part, and your first operating system need to know. So this is hardware, this is a device program, for example. Then your operating system understand control your device program, then the kernel and application program. Finally, the other side is the terminal application, such as a shell program or desktop. Okay, or CLI to use. So this is a layered approach. Benefit as a paper cut because of it. So what is the benefit of using such an approach instead of this one? For example, to use this operating system, you need to build all of this, then compile all of them, then use it. However, what about this one? If you are not ready this, you can start from the kernel, okay, and add the additionality. So it can be easy to develop, okay. Also, somebody would like to use the existing layer, existing module, but I'm interested to change only this part, layer, the outside layer for the new interface, new graphical user interface. You don't have to worry about it. You don't have to change this, only change outside, okay? So this is the layered approach. However, problem, you need to, any kind of, this is not the layered approach, it's not only for this operating system, many other, even the software may have such a layered approach, okay? So main problem, you need to communicate between layers. So to access the hardware, if you allow this one directly here, you can do that, but it will be messed up. Like this one, it will be like not messed up, you just integrate, centralize the approach. But in this case, to communicate, you need to communicate here, communicate. So finally, it will be access the input and output. It takes up time, it will be overhead. Okay, so that is a layered approach. Another approach of such operating system structure is called the microkernel. Microkernel is one of the trend in the operating system to build the kernel is as small as possible. If big, so I like to put everything inside, your operating system will be slow and very hard to maintain, like the Windows system. Okay, but if you build a minimum kernel operating system, then you are able to add and more things. So for example, the macOS use the kernel, it's called the Mahu, which is called the Mahu. So it's a microkernel. Okay. So for example, here. So this is the very high level the operating system structure of the Mac OS. So for example, this is a hardware part, and then at the kernel part, this kernel is a minimal kernel, which is called the Mahu. Then in addition to the Mahu, it has a BSD. BSD, have you ever heard about? So one of the main branch of the Linux kernel, they adapted this part as a part of this. Okay, instead of developing the all of this kernel and adapt it. Because of that, you are able to access the Apple book or MacBook hardware through the command line, the BSD bash shell. Okay, so this then on top of that, there is an application environment like the Object-C and so on. So and also it supports the BSD, the library like the GCC and the other. Because of the reason, some of the researchers still use the MacBook and use a lot for the library. Then they use the MacBook for the C program, C++, low-level programming also. Okay, then the graphical user interface can be on top of that. So that is another approach, so microkernel system. Okay. Then some of the operating system follow the kind of the object-oriented concept in the software engineering, like the modular approach. So we have only one kernel, and the kernel is connected to all the module or some of the selected modules. So for example, I need the file system scheduling and the device control, only this one. Then you can purchase actually only this module when you buy the operating system. This is really helpful. We didn't know that 20 years ago when we purchased a Sun Solaris system. Then from the Sun Solaris we purchased the hardware and the operating system and we expect that everything is inside. Then try to compile, there is no GCC. But at the time, there is no CC program. So at the time, it's not like the internet based, so it's very hard to get the C library, the C program. So we called some microsystem. They said we need to purchase by paying. So how many users do you need? So we have 100 developers. We need to pay for 100. Then they enable. Actually, it was there. Just key then we can use the programming library also. It's modular based. So this approach, but nowadays I don't see many of that because of the open source. Open source is not architecture, but it is based on such a modular. So you can add the library or system library or function or enhanced one. Then rebuild. Based on the major kernel, you can rebuild it, like the version 1.2.1.1.2. So you can add such a contribute in the open source community. Nowadays, many of the operating systems combine all together, like the Mac OS. Actually, it's not only the as you can see, some of them are modular, some of them are based on the microkernel. So it's called the hybrid. The system. Also, one more important concept in the nowadays in operating system is the portable device. So portable device. So this one, what is this? This is also computer. So it has a hardware. We need an operating system. There are two main, but actually there were many. There exist the many other, even the Microsoft Windows, they have the mobile device operating system also, such as the iOS, Android, Symbian, others, Windows, the P, what is the name of the personal edition, P or the whatever. So there are many. So their basic architecture are the same as what we have seen, but it has the different characteristic. One of the main difference between the cell phone device and computer is what? Size? Power. So power is the most important part in the computer system, which is easily ignored by the computer science student. The power is very important. Like the computer laptop, so you are struggling. After 1 or 2 years later, the battery power is reduced. And also, like nowadays, the data center, we build the data center. Whenever you connect the GCP, actually the physical location of your virtual machine may be in the New Zealand or the China or something like that, but you may not realize. However, when they build the data center, most important problem is the power. And that power creates what? Heat. So it needs to cooling down and the energy. So that energy. So one of my, actually it was interesting, so several years ago I attended one conference. Then I met suddenly my old friend, the elementary school, I think the 10, 12 years old. We met 30 years ago, but we meet again in the conference. Then we exchanged the long time history. Then he was the IBM designer, the chip designer. IBM actually well known for the processor, like the IBM power chip and so on. It has been long time, but as you know, IBM throw away all hardware business. They sell the Lenovo PC to the Chinese company, and the power chip, they no longer support the designing the power chip and everything. Then they move to the data analytics and AI software part. Okay. So, however, today fire all the people who worked for the hardware? No. So he actually moved to the white plane. In the white plane, his job is designing, actually work with the government and city. When the city government design their town, the most important part is the utility. Okay? You cannot change the right-of-way street. Okay? The Fifth Avenue combined with the Fourth Avenue? No, you cannot do that. But mostly maintained. But the power is different. If we lose the power, you may not realize, but several years ago, just like the hurricane, the Irma, so hurricane, the Sandy hit this area. So we lose the power a week. Anyone who at that time? Yeah. It was really, even before that, we have several times of the losing power for a week here. So it is really painful to live without power. What about the town? It's more serious. Like some people lives in the 50-story building, losing power, elevator. So there is actually part-time job who deliver the water. Really, that happened in New Jersey and so on. So in case there is no power or like the hurricane, why don't you go to such a high-story building? Then they do make the money. Yeah, they cannot come down just if they ask the water, then you can deliver the water. Like the $10 of the gallon. So his job is designing what? The city. The power plant. It's exactly, he said, exactly same as designing the chip, computer chip. Okay? So power is such an important part of the computer system. So by considering this, think about how can you manage reduce the power consumption in the computer system. You allow only one process at one time. Think about your laptop, how many processes are running? A lot, especially the Windows. Windows is really bad to start a computer system. So when you click, it takes a long response time. To address that one, actually, operating system put as many processes as possible on the memory. Then you may not realize that. However, if you check the task manager, there are a lot of processes are running background service program. It's called the daemon process. We will see the detail. So, however, if we allow such a multiple process background service, you will lose the battery very quickly. So only one process. Nowadays, you can select some of the process. Okay, like the messenger, you don't want to lose the disconnected from your friend. So you can always own the specific application, not all program like the Windows. Okay, that is the one of the important thing you need to consider when you design such a portable operating system. Then they have kind of like, so basically it's the same component as the typical operating system. Okay, but it's a service by service. So like some of the core service, and it is important to process the media. It's a data, but mostly what is the most the frequently used data type or the storage video and in the portal, right? So we are using even though iPhone released the new version recently, so iPhone 8 and iPhone X. What is the difference? It's expensive, getting expensive. It's $1,000, even though it's $99.99, whatever. So media is the important part. Also, that's also important thing for computer science student. So we are talking about always the data analytics, data whatever, big data. But it's mostly 99% deal with the text data nowadays. But eventually it will be image data and video data. Okay, so why don't you consider such an opportunity in future? Okay, also I think